For the next example, we are given that a student is standing on ground level and throws some keys to a friend on a balcony 4 meters above the student. So I'm going to draw a picture of that. Here is the balcony, here is the student on ground level, here's the friend reaching over the balcony, and the student throws the keys up to the friend. Now, we're going to assume that the keys essentially begin at ground level and the keys are caught when they are 4 meters above ground level. Technically, yeah, you throw a little above ground level, but we're ignoring that. So the question is, if the keys are caught 1.5 seconds after they are thrown, with what velocity are the keys thrown and with what velocity are the keys moving when the keys are caught? So I could think of this problem. You have some keys, you throw them up to a friend on a balcony. So you would throw your keys up to your friend and your friend would catch them just like this. So this is essentially a 1D motion problem. But there's another way we could think about this scenario. What if I have my friend on the balcony, I'm down here on the ground, and I throw my keys, but instead of catching my keys initially, my keys go above my friend and my friend catches them on the way down. So we don't really know what's going on with this problem right now. How do we know to differentiate between these two scenarios and find out which scenario is actually happening? So let's just label a few things that we do know are going on in this problem. Again, as always, I want to set ground level to be 0. So I will say the keys begin at ground level, y initial is equal to 0. When the keys are caught, they are 4 meters above ground level. So y final is equal to 4. This is true in both cases. Also, the moment I release the keys, the moment my hand lets go, we ignore air resistance, the keys are in free fall. The only thing affecting the keys' motion is the gravity of the Earth. So if the keys are in free fall, the acceleration will be negative 9.8 throughout this problem. Also, I'm just going to quickly mention, technically I drew the keys moving a little bit to the side, but we're doing 1D motion in this chapter, so pretend the keys move up and down in a straight line, just in a straight line. They're not moving to the left or right in any meaningful way. So in this case, I throw the keys straight up. My friend is not quick enough to grab them when they move past his hands, but then my friend turns his hand and catches them on the way down, so they still move in a straight line. So the question is, what is V initial? And another question I'm going to pose, how do we differentiate between these two scenarios? How would we know what scenario is actually happening? To answer that question, let's think about what are the keys doing when they're caught. In this scenario, the keys are moving upward when they are caught. And if I think back to upward motion is positive velocity, downward motion means negative velocity, the keys are moving up and up and up. And so in this scenario, the final velocity of the keys is going to be some number bigger than 0. In this scenario, the velocity of the keys, they're moving up, but they go past my friend, and then they begin to fall. And in this scenario, the final velocity of the keys is going to be negative because here the keys are moving downward. So if we find the final velocity and calculate a number for it, if we find a positive number, that means this scenario is correct. If we find a negative number, this scenario is correct. Regardless, we are also given that the keys are caught 1.5 seconds after they're thrown. So in both cases, I could say t is equal to 1.5 seconds. So the first thing we're going to do, with what velocity are the keys thrown? I don't know. Let's look at all these equations and let's see. Instead of x, I'm just going to pretend these are y's because I'm now talking the vertical direction. Otherwise, I don't really need to change anything. Do I know the final height? That's 4. Do I know the initial height? That's 0. Do I know the initial velocity? No. Do I know the time they're caught? Yes. Acceleration, we know that, time. So I could use this first equation to find the initial velocity with which the keys are thrown. So if I say y final is equal to y initial, v naught t, 1/2 at squared. Okay, y final, final height of 4, initial height of 0. With what velocity are the keys thrown? We don't know, so I will leave that as just v naught. The time the keys are caught is 1.5 seconds plus 1/2, negative 9.8, 1.5 seconds squared. So now I have an equation, a whole bunch of numbers, and a v naught, so I could just go through, do the algebra, and solve. So I would get 4 is equal to 0, I won't write it, 1.5 times v naught. I'm just more comfortable having the number in front of the variable. It doesn't matter what order it's in. Then 1/2 times negative 9.8 times 1.5 squared, that gives me minus 11. I need to remember the negative sign here is important. Writing positive 9.8 will change a number. That will change my final result and give me the wrong result. So be careful, make sure you include negative signs. So 11 plus 4, that's 15. So I get 15 equals 1.5 v naught. And so my initial velocity of the keys is 10 meters per second. Okay, we know the initial velocity of the keys. We have one more piece of information that we know. So I could say 10 meters per second. Notice also, we got a positive number here indicating the keys are thrown upward. And very intuitively, you know if you want to throw your keys to your friend above you, you got to throw them upward. So this positive number just indicates again that the keys were thrown upward to reach the friend. So now we are going to try to find what is the final velocity of the keys. And if we get a positive number, this will be the picture because the keys are moving upward the moment they're caught. If we get a negative number for velocity, this is going to be the picture because the keys are moving downward when they are caught. The next part of this question asks, what is the velocity of the keys the moment the keys are caught? So we already used this first equation of motion. I probably won't want to use it again. Also, I recognize there is no final velocity in here, so it doesn't seem immediately helpful to us. I could look here, I see I have a final velocity. I could look here, I see I have a final velocity. So right now, both of these equations look pretty useful. I could next go through this equation. Do I know the initial velocity at which the keys are thrown? Do I know the acceleration of the keys? Do I know the time at which the keys are caught? I know all three of these terms, so I could plug numbers in and just get an answer for the final velocity, and that's great. I could ask the same question about this line. So do I know the initial velocity at which the keys are thrown? Do I know the acceleration of the keys? Do I know the initial and final height of the keys? I know everything on the right-hand side of this equation also. So for the moment, it looks like both equations could be used to solve this problem. But let's not jump to that conclusion so quickly. Let's think about what we're really trying to do. There are two possible scenarios for this problem. One scenario will have a positive velocity indicating the keys are caught when they're moving on the way up. The other scenario will have a negative velocity indicating the keys are caught when they go past the person on the balcony and are caught back on the way back down. Now, I don't know what the final velocity of the keys is going to be because we haven't solved this yet. But let's say we plug numbers into this equation, we do some math, and we find v squared is equal to 16. Well, When I say v squared is equal to 16, then I would want to solve for final velocity. If I take the square root of both sides, I would get v, but then I'm going to have two possible solutions for v. I could have v equals positive 4, or I could have v equals negative 4. So even though I have all the terms I could plug into this equation for finding what v final is, I still will have a certain ambiguity as to which equation actually matches up with which scenario. Now, this does indicate that the velocity at which the keys are moving upward, right here, will be the same as the velocity with which the keys are moving downward right here. So the speed of the keys will be the same at both locations. Only one is going to be up, the other is going to be down. But still, we do not have enough information to differentiate between these two scenarios based on this last equation here. So I can't use it to actually answer the question. Which, in any case, I would probably rather go towards using this equation just because mathematically it's easier to work with. I don't have to worry about the square, there's fewer terms to worry about. So I could say v is equal to initial velocity of 10, acceleration of negative 9.8. The time the keys are caught is 1.5 seconds. And right away, looking at this final answer, I could see that this is going to be the final scenario. So how could we see that very quickly? Well, what I did was I see 10 here, and I see a number that is nearly negative 10 right here. So 10, I could think of it as 10 and negative 10 would tend to cancel each other out. But this number that's nearly negative 10 is being multiplied by something significantly larger than 1. So when I multiply this thing that is almost negative 10 by something else, by this other term, this is going to be significantly more negative than negative 10. So if I put numbers in the calculator, I would get v is equal to 10 minus 14.7. So v is going to be negative 4.7 meters per second. So what I find is if you're moving downward because you have a final negative velocity, that indicates this picture is what's actually going on in the problem. And this picture is physically possible. It can happen, but this is the picture that actually happens 1.5 seconds later. So this is not what really happened in this scenario. The keys were moving at a velocity of 4.7 at this moment here, but they were moving at that velocity before t equals 1.5. They were moving, I don't know, sometime much earlier than that. The final part of this problem asks you, what is the total height that the keys reach? So what is this maximum height right here? So how should we think about this problem? I am going to redraw this picture, but when I redraw this picture, I'm going to exaggerate it a little bit. Technically, the keys just move straight up and straight down, but I want to draw within that picture, so I'm going to draw it with a bit of an arc, even though the keys do not move left or right whatsoever in this problem. So let's say here is the friend on the balcony, and then 4 meters below, I'm going to draw the friend over here. And the keys go straight up, reach their maximum height, and are caught by the friend. Again, the keys actually do not move to the left. I'm just exaggerating this so I could draw within this picture. Now, in this problem, for the first two parts, we said initial and final. But sometimes you could have problems that are a bit more extensive than that. So initial and final are arbitrary based on whatever is useful to you at the moment. For parts A and B of this problem, I said this was initial and this was final down here. But for part C of this problem, we want to know how high the keys are when they're up here. So I'm going to instead call this the final moment now. So the final moment will occur before the keys are caught. I'm just redefining what I mean as final to be something that is useful based on what I'm trying to solve at the moment. Now, when I do that, I need to be careful. Some of these final values might change. So, well, if the keys are caught at 1.5 seconds, I know the keys will reach their maximum height before 1.5 seconds, so I can't use this as my final time anymore. And the keys are caught at 4 meters up. We know they're going to go higher than 4 meters. My final height is not going to be 4 meters. So, my final moment, I do not know what T final is for part C of this problem. I do not know what Y final is for part of this problem. Well, throughout all these 3 equations, we have 6 terms that we can possibly assign values to. So we have Y initial, Y final, V initial, V final, A, and T. So T, we do not know what that is. Acceleration is negative 9.8 because we're still moving under the influence of gravity. Y initial is 0. Y final is ultimately what we really want to know. V initial is still going to be unchanged. We're just looking at an earlier moment than 1.5 seconds, so this will still be 10. There's one term left, V. What is V final? What is the velocity of the keys when they're at their highest point? So I am going to claim that the velocity of the keys is 0 at their highest point in the vertical direction. Now, I am going to, before I go on, I'm going to explicitly say, in the vertical direction, when you reach your maximum point in free fall, your velocity, your Vy is 0. I am being very explicit about saying in the vertical direction because in this chapter, it doesn't matter. I don't need to say more, but in the next chapter, if you're moving in 2 directions, your velocity in the y direction could be 0 when you reach your max height, but your velocity in the x direction does not need to be 0. So I want to be very explicit with that. We'll talk more about that later. Okay, so I claimed that the velocity when the keys reach their maximum height is going to be 0. How can I justify that claim? Let's look at when the keys are thrown and when the keys are caught. The keys are thrown with an initial velocity of 10 meters per second upward. So here is 10 meters per second. The keys are caught when they're moving upward. When the keys are caught over here, they are moving with a velocity of negative 4.7 meters per second. Now, gravity is pulling the keys downward. So when the keys are here, they're still moving upward, but they're not quite moving that fast. So they're going to be moving slow upward, but slower. So maybe, let's say 7 meters per second when they're over here. And the keys are still moving upward, but gravity is pulling them down. So the keys will still keep going up and up, but gravity is tending to slow them down. So when the keys are over here, maybe they're moving 4 meters per second. Let's look at the other side. When the keys are moving downward, gravity is pulling them down. Gravity always pulls downward. So here the keys are moving 4.7 meters per second. When the keys were here, they were also moving downward, but they were not quite moving as fast downward. Maybe the keys were moving at negative 3 meters per second. Right here, the keys are moving at negative 3 meters per second. Gravity pulls them down. As gravity pulls them down, that will tend to make the keys move down faster. And up here, the keys might be moving downward, but at negative 1 meter per second. Let's look at the other side. Up here, the keys might be moving with a velocity of plus 1 meter per second. Positive 4, positive 7, positive 10. If you follow the pattern, we started with a big positive number, then a less big positive number, less big positive, less big positive. Skip over the top part for the moment. We have a negative, more negative, even more negative. So at the top point right here, a split second before the keys reached the top point, they were moving upward. A split second after the keys reached the top point, they were moving downward. So if we zoom in on this part of the picture right here, here's the keys just before they reach their high point, just after they reach their high point. So here's the high point. When the keys are here, they might have a velocity of plus 0.1. And when the keys are here, they might have they're moving upward. They did not reach the top point yet, so they're still moving up, so they still have a positive velocity. The keys might have a velocity of plus 0.001. When the keys are here, well, they were at the top point, now they're moving downward. So here the keys might have a velocity of negative 0.001. And when the keys are here, they're moving downward, they might have a velocity of negative 0.1. In order to go from positive 0.001 to negative 0.001, you have to go through 0. At a split second beforehand, before the top point, the keys were moving up. They had a positive number for their velocity. A split second after they hit their top point, the keys are moving down. They had a negative number for their velocity. To go from positive number to negative number, you must travel through 0. So at the top point, the velocity in the vertical direction of the keys is equal to 0 at their maximum height. So I could say v equals 0 at max height. This will be a very useful piece of information to solve equations with. Now, again, I want to emphasize, we are looking at a 1D motion problem. I want to emphasize that the velocity in the vertical direction at maximum height is 0. But I want to say something about where we're going in this course. In this particular problem, where the keys only move up and down, the keys only move in a line, it is true that at maximum height, the keys are going to have a velocity of 0. But what we're going to do in the next chapter is we are going to consider motion in 2D. So we might have an object that is moving in an arc, something like this. Now, the way we are going to write velocity is, in this chapter, we said v is equal to delta x over delta t, assuming we're moving left-right. Well, what if we're moving left-right and up-down? Now I want to say the velocity in the x direction will be your change in x with respect to time, and your velocity in the y direction will be your change in height, your delta y, with respect to time. At this moment, the change in height is going to be 0, but when I'm looking at 2D motion, where you have some object flying through the air in some type of arc, I could look at this picture and I could say this is going to be the high point of motion. By the exact same arguments that I mentioned before, I could say Vy, which is delta y by delta t, is going to be 0 at the high point of motion. But at the same time, Vx, which is delta x over delta t, in this case, Vx is not going to be 0. It will be some number, something non-zero. So it is wrong to say that at the high point of motion, the velocity is 0. It is correct to say at the high point of motion, the velocity in the vertical direction is 0. it is very explicitly shown in this case when we have a horizontal and a vertical part of the velocity. In this problem, we only have a vertical part of the velocity, so I can claim that at the high point of motion, the velocity is 0 for this problem, just due to the fact that I'm dealing in 1D motion and the object is only moving up and down. But in general, that is not always going to be the case in 2D motion specifically, so I want to emphasize that right now. But this is something we're going to talk about next chapter. It doesn't really matter for what we're doing in chapter 2. So we said that at the high point of motion, Vy is 0, and we are asked to find what is y maximum height, what time, we're not asked to find that, so we don't need to. So I could look at these equations and I could see, okay, well here's a final position, here's a final position. So I could write out the first equation, y is equal to y initial plus v naught t plus 1/2 at squared. Okay, let's see, do I know, this is really what we want to find, so we definitely need that. I know that, I do not know this, I know that, again, I don't know that. So I would need some equation to give me time, and then I would then be able to plug in time and solve for maximum height. So I could then say v is equal to v initial plus at. I know what v final is, that's 0, that whole rant I just went on. I know v initial is 10, I know acceleration. So in principle, I could use this equation, I could do some math, find t is equal to, I'll get some number, then plug that in there, and I would go ahead and solve the problem. Or, let's see what the third equation looks like. By the way, this method that I am outlining here would be perfectly acceptable on a quiz or exam or anything else you might see. So if you use it, that's fine. Let's say I want v squared is equal to v initial squared plus 2a y final minus y initial. V final is 0. V initial is 10 squared. Plus 2, negative 9.8. Maximum height is what we want. Initial height is 0. And looking at this equation, this is going to be fewer steps. Again, not that using the two equations would be wrong, it would be perfectly acceptable. If you don't like having lots and lots of equations, you could do this entire chapter with just these two equations. But if you prefer, having this third equation in your arsenal could sometimes save you some lines of math. So do whatever you're more comfortable with, whatever your preference is. So I could say 0 is equal to 10 squared is 100. 2 times negative 9.8 becomes negative 19.6. So minus 19.6. Y minus 0 becomes y, and I'm multiplying y there. Again, negative sign, I need to be consistent. So from there, I could bring 19.6 to the other side, plus 19.6 times y, plus 19.6y. So then 0 plus 19.6 is 19.6y. 19 plus 19.6y, I mean, 100, and these canceled. So if I divide both sides by 19.6, I find the maximum height of the keys when they reach right up here is going to be y final is equal to 5.1 meter. So this was a height of 4 meter, and the keys at this moment here are at a height of y equals 5.1 meter.